Welcome everyone. This is going to be the first of many videos talking about acids and bases here in chapter 16. So first we need to define what are we talking about with an acid and base. And that can be tricky because there's actually through the years been multiple definitions of acids and bases. So originally Arrhenius came up with the definition of hydrogen ion H+ being an acid, and the base being OH- hydroxide. Okay, that was later definition kind of improved upon with Bronsted-Lowry definition, where your acid is a proton donor and your base is a proton acceptor. And then that was further improved upon by the Lewis definition, where you have an electron pair acceptor and electron pair donor. So we'll mainly focus on the Bronsted-Lowry definition of an acid and a base. Okay, in this class we'll briefly talk about Lewis near the end of this chapter, but for the most part we'll focus on Bronsted-Lowry definitions of acids and bases. Okay, and right, each one of these new creations of definitions of acids and bases is not someone deciding let's call it something else. It's expanding upon the idea. So anything that is an Arrhenius acid and base is a Bronsted-Lowry acid and base. Anything that is a Lewis acid and base is also a Bronsted-Lowry acid and base. So it's not that we're changing what our definition and getting rid of old things. It's more each one of these new definitions of what an acid and base is in chemistry is trying to broaden our description of what we can consider as an acid and a base. Okay, you can kind of imagine, right? We start off with our Arrhenius definition, which then gets encompassed by the Bronsted-Lowry definition, right? Which then gets encompassed by the Lewis definition, right? And so it's not, they aren't describing completely different things. They're just different ways of describing the same thing that then allows us to incorporate other types of chemical reactions into this idea of an acid-base reaction. Okay. So, right, we talked about these hydrogen ions. The hydrogen ions are just a proton, right? It's the hydrogen atom minus the electron, right? H+, it means you removed an electron. So the hydrogen ion is just a proton, okay? So we'll talk about hydrogen ions. Typically, that's what we'll refer to them as hydrogen ions, but really it's just a proton floating around, right? But we'll use this term hydrogen ion, but just to kind of keep in mind, right, what that is. It's just a proton, okay? Now, in solution, you don't really have like a hydrogen ion by itself. Typically, what you have is the hydrogen ion will react with the water to form what's called hydronium ion, okay? So hydronium ion is H3O+, okay? Right? And so throughout this class, throughout the book, throughout all aspects of chemistry, you will see things written sometimes as reactions of like H+ plus say OH- forming H2O, right? You might see the reaction written like that, or you might see this exact same type of reaction written as H3O+ plus OH- goes to 2H2O, okay? And while these, just looking at those written reactions look like they're slightly different reactions, okay? They really are describing the exact same thing and the exact same type of reaction. It's just depending on the situation, the person even, people will sometimes write H+ ions, hydrogen ions, and sometimes people write hydronium ions, H3O+. I'll often just use H+ hydrogen ions just because it's easier, right? It's easier to write H+ than it is to write H3O+. Just faster, simpler, right? But they're the same thing, okay? Right? Right. I tend to try to think of like what's in a name or whatever. A rose is a rose, smells the same, or so. I don't even know the poem or something, right? But point is, right, that you can call hydronium or hydrogen ions are referring to the exact same thing in solution, right? That hydrogen ions don't exist in solution by themselves. You don't just have a proton floating around. This proton will attach itself to a water to form a hydronium, okay? But we just, it's kind of assumed like that's what's going on. So whenever I write a reaction that's like H++ NH3 going to NH4+ or something like that, right? It's just kind of assumed in solution, right? If all these things are aqueous, right? All these things are in the solution of water, right? That means that this H+ is really H3O+, okay? But again, we just kind of gloss over that often, and I say we use chemists and things of that nature. So you'll see both those definitions used. So just keep that in mind and don't get, and hopefully it's not confusing when sometimes you see H3O+ and sometimes you'll see H+. Okay. So if we're talking about kind of our Bronsted-Lowry definitions of acids and bases, we're often talking about proton transfer reactions, right? So proton transfer, right, is H+ transfer, right? So I'm transferring a hydrogen ion from this, right, hydrochloric acid over to ammonium, okay? Right, form Cl- and NH4+, okay? Right, but you see that hydrogen is being transferred. So any Bronsted-Lowry acid-base reaction involves the transfer of a hydrogen ion or a proton. Okay, a transfer of a proton is that hydrogen ion, right, that's being transferred. Okay, and again, in the Bronsted-Lowry definition of acids and bases, the acid is the thing that donates the proton, and the base is the thing that accepts the proton. Okay, so acid, proton donor, base, proton acceptor. You need to remember those definitions because we're often needing to identify what is an acid and base in a chemical reaction. Okay, so keep in mind what these definitions are. Okay, so to finish up this video, right, let's just define what is an acid and base in this reaction, right? Well, HCl here is donating a proton, so this is going to be our acid, and then NH3 is accepting that proton, so this will be our base. Okay. So this acid will react with a base, and in that reaction, a proton is being transferred. Okay. All right, and so that's it kind of for this kind of basic definitions of acids and bases. Okay. Right, you're going to want to keep these definitions in mind as we go through this chapter and other chapters throughout this semester.